Hello and welcome to Layer 7's webinar on how to choose a SOA or XML gateway. My name is Dana Crane and I'm the Product Marketing Manager here at Layer 7. And for those of you who aren't familiar with Layer 7 technologies, we've been a leading vendor of SOA gateways since 2003. We're primarily aimed at the Global Fortune 1000 and government organizations, and we've enjoyed a wide industry recognition over the years. And we're currently featured as a leader in Gartner's Magic Quadrant for SOA governance. But that's not what you came here to hear about. You can read more about us on Layer 7 on the website. What you want to hear today are the kind of pointed questions you can ask of any vendor, any SOA gateway vendor, in order to help you understand just exactly what you're getting yourself into before you make your purchase. And to that end, I'll be running you through what I call the abilities: extensibility, deployability, upgradeability, and so on. You get the idea. And finally, I'll leave you with some thoughts on TCO. Now, if you have any questions along the way, just type them into the chat window and we'll capture those and get back to you after the session. We want to make sure we have enough time to follow up properly with each of you. So let's get started. SOA vendors offer a wide range of solutions, everything from heavyweight enterprise service buses to lightweight endpoint security agents. And any one of those could be right for the class of problem you're trying to solve or the architecture you've got in place. SOA gateways, or XML gateways, some analysts prefer to call them, they're a good fit for the kinds of use cases you see listed here. They essentially provide security, control, and visibility for SOA initiatives and web-based publishing of APIs or connecting or integrating to cloud-based services. Organizations confronted with these kinds of use cases have a number of vendors to choose from, including everything from best-of-breed independents, like ourselves, to giant multinational corporations. But despite solving the same kinds of problems, each of these vendors have taken a very different approach in creating their SOA gateway. And those approaches have resulted in some pretty interesting trade-offs. I think you'll see that as we go through our slides. For example, when it comes to form factors, some vendors offer only hardware or only software-based appliances. Now, hardware is a good choice for production deployments in traditional data centers because of the high performance capabilities, but it's not typically the first choice for developers or QA personnel. They just don't need the horsepower or the headache of managing a shared resource. For example, most hardware vendors offer the ability to segment a single gateway for use by multiple developers. You know, in theory, that sounds like a really good idea. It's a cost-effective solution, but it can become problematic when one developer needs to restart or reconfigure the gateway to suit their specific use case requirements. Nor does the hardware fit very well with the general IT trend away from physical resources to more cost-effective virtual and cloud-based environments. But no matter what form factors your vendor supports, make sure to ask whether they all offer identical features and functionality. And that will allow you to select the best form factor to match the environment, your budget, and the requirements for your current project. But whatever form factor you choose, your gateway will need to interoperate with all your existing internal systems as well as external resources too. Nowadays, most independent gateway vendors provide standards-based, out-of-the-box support for the most popular identity and access management systems, such as Tivoli's Access Manager or CA's SiteMinder, provide support for queuing systems, such as WebSphere MQ or JMS queues, and they may even have built-in secure token service capabilities for resolving identity federation issues when it comes to integrating with your partners and your cloud-based resources. All of this functionality is typically built right into the gateway, or else it's available as an optional add-on to be installed directly on your box. But large multinational vendors are often forced to take a proprietary approach to interoperability simply because of the way they're divisionally set up. So if you need to do federation, for example, they'll have to bring along their identity group. Or if you need to do customization, that's their application development group. And if you need to integrate it all together, they may even trot out their consulting arm as well. Does that sound familiar? Well, then you've probably been on the receiving end of that kind of pitch before. You know, the one where you find yourself faced with a bill of goods that includes the vendor's proprietary UDI, their app server, their IAM infrastructure, their cloud gateway. All those will indeed solve your use case, you know, make no mistake, but when it comes to what will come at the cost of vendor lock-in. So if you want to continue to pick and choose the best product for your requirements, make sure your vendor not only talks the talk about third-party support, but is truly committed to them as well. This is especially true when it comes to integrating multiple platforms. So here's some examples I'm going to throw in here throughout the slideshow, give you guys an idea of some of the customer implementations we've actually done. In this diagram, it represents a real-world example of a Fortune 500 company that grew through acquisition. It didn't standardize on a single IT platform. Now, if that's similar to your company, you'll need to look for a SOA gateway that can coordinate, provide you with cross-domain mediation between all your different systems. For example, here, you've got Microsoft.NET-based applications built on WCF and authenticating via Kerberos. You've got Java applications built with J2EE and using SAML tokens. You've got mainframes that employ COBOL copybooks, and so on. The more platforms your vendor can support out of the box, obviously, the lower your integration costs will be. Let's talk a little bit about extensibility or customizability in general. That's a broad and deep topic, and for lack of time today, I'm only going to touch on it. Suffice to say that all the XML gateways on the market today can be customized to accommodate just about any use case. The choice really comes down to how cost-effective customization will be for you, given your existing resources and your skill sets. For example, some gateway vendors offer Java-based customizations. We do, Layer 7. That makes them a good choice, makes us a good choice for Unix shops and Java programmers. But Windows-based organizations may want to look for a gateway that supports customizations in .NET with C#, or XML purists may even prefer to code directly in XSLT. In any case, to minimize your customization effort, you'll want to ensure your code can be run directly on the gateway. That allows you to avoid introducing an app server, forgoes the necessity to integrate with it, or even support that extra server. I'll give you a good example here from our customer set. This is an example of running custom code Onboard helped to keep this project on time and on budget. It's one of Layer 7's customers. It's a national healthcare provider. They had a constrained budget, and they were concerned with the rising cost of delivering healthcare services nationally. So to decrease costs, they decided to implement a nationwide electronic patient record. But they didn't want to reinvent the wheel by creating a new centralized system, so they went with a decentralized solution. So here, the Layer 7 gateway sits in the center. It acts as a hub, and it gates access to all the patient records, which remain where they started, at their local pharmacies or hospitals or doctor's office or clinics throughout the country. The key here was being able to maintain patient confidentiality and privacy. They wanted to ensure that only registered healthcare professionals could be authenticated to that system. So they issued every healthcare provider with a personal Java card. When you swipe it, it creates a special logon token. But that token required some complex security validation involving SHA-256-based signatures and custom token extensions. And what happened here was the Layer Gateway provided them with a secure token service directly on board. It's one of our built-in capabilities, along with some PKI capabilities we have as well. So we were able to accept that proprietary token, and with just a few lines of code directly on the box, we were able to translate it to a standard token that each of those back-end services, at the lab services, at the pharmacy, at the doctor's office, were able to understand. So as a result, that national healthcare provider was able to meet their budget for the project because they could eliminate the need to update all those existing systems in their healthcare system. They didn't need to accept the Java token. We could translate that token into something they could understand. But it also eliminated the need to integrate the gateway with a separately deployed app server running a secure token service or a PKI service and running that custom code as well. I want to talk more in depth about manageability, though. So I'm going to go into some depth here. And there's really just two use cases, or two cases that you should be concerned with. There's smaller deployments, say around up to 5 gateways, and then there's the global deployment. We'll talk about that in a minute. So for smaller deployments, what you would want to look for is gateways that provide integrated clustering capabilities. That means the gateways automatically replicate information between themselves, allowing you to, for example, update a policy on one gateway and have that policy automatically replicated across all the gateways in the cluster. Even with 2 or 3 gateways in production, having a single point of administration greatly simplifies the management burden here. But integrated clustering also provides benefits when it comes to scalability. You can literally just drop in a new gateway in this configuration and scale out your implementation. Also think about reliability. There's no master node here in this clustering. So if one gateway goes down, the system automatically falls over to the other gateways in the cluster. Solutions that offer built-in clustering and failover can go a long way to ensuring reliability, providing fault tolerance and high availability. Let's get to one of those examples again. So another benefit of integrated clustering, besides what I've just talked about, is the ability to implement a cluster-wide counter almost instantaneously. So that allows you to guard against replay attacks, or here's a good example, enforce contractual limits with a high degree of accuracy. So this slide is a simplistic representation of the architecture of one of Layer 7's telco customers. They offer cellular phone services to their customer base on a contractual basis, and the typical services include SMS or MMS messaging and the ability to download ringtones or IPTV shows or even iPhone applications. So in order to facilitate such a service delivery, the telco needed to be able to not only associate each customer with their contract, but also to enforce the terms of that contract. So in other words, they wanted to prevent access to the service if the customer exceeded their contractual number of text messages or downloads per month. So in this scenario, the Layer 7 gateway acts as a policy enforcement point. We enforce the telco's business rules with respect to the services that they provide. Now, when the customer attempts to access one of the telco's services, the gateway authenticates them and performs a lookup against the contract to determine which services the customers can access. In this scenario, the gateway increments the counter for each customer across the entire cluster of appliances. And that's key to being able to determine when that contractual quota has been exceeded. If it's exceeded, the gateway can then send a message back to the customer informing them they've exceeded their quota, and then prompt them to upgrade to the next level of their service contract. So what happens if you don't have integrated clustering? Well, you have to make a call back to the load balancer in order to increment the cluster-wide counter. Now, in theory, that round trip shouldn't introduce significant delay, but in practice, what we've found out there in the field, especially for service providers that have a really high volume of digital traffic, Pascal, as shown in this example, he may end up with being allowed 202 messages per month, or even worse, maybe he'll end up getting cut off at 199 SMS messages and becoming a headache for your call center team. So let's get back to manageability, that other use case I was talking about. Let's talk about larger enterprise-wide deployments involving tens or even hundreds of gateways. So here you'll want to use the same kind of centralized management capabilities on a cluster-by-cluster basis as you have with the smaller deployments, but you'll probably also want the ability to roll up performance and metrics across your extended enterprise. Now, most gateway vendors take a local approach to global management. That means that each region deploys and maintains and updates its own management infrastructure to manage the local deployments. And that's a pretty good solution for enterprises, since they're mostly composed of autonomous divisions that create and maintain and use their own set of services. But you want to be aware that if you go this way, getting a real-time roll-up view across your entire SOA landscape will require a separate solution, maybe something like an HP OpenView or Progress Software's ActionL. Now, other gateway vendors, us included obviously, we embed our global management functionality directly within the gateway itself. It doesn't matter what the form factor is. And that allows you to manage all of your gateways across your geographies and between data centers and even cloud providers from a single central location. You want to ensure you understand from your vendor exactly what your options are here when it comes to local versus global deployments. Now, another key manageability consideration for SOA gateways is service migration. Most enterprise services rely on an assortment of external IT resources to operate. Things like directories and identity and access management systems and message-oriented middleware providers, log and audit syncs as well. Now, these external dependencies become issues whenever an application is moved between an environment. For example, consider an LDAP in an Asia-based development organization. Well, it's probably going to be named differently from the LDAP located in your cloud-based test environment, which in turn is probably going to be named differently from the LDAP running in your production centers. And that's just one external dependency. When you think about these environments, they're pretty complex. They include things like queue names and trust relationships, and of course IP addresses and URLs are going to be different. You've got shared clusters, you've got variables, you've got key names, global schemas, you've got certificates, you've got WSDL documents. The list is almost endless. And all of this raises the complexity of any migration you undertake. All of these things are going to need to be remapped when you move your policies between each of your environments. Now, unfortunately, most gateways just provide a little benefit here. They leave you to bite the bullet and manually migrate your policies between environments. Some gateway vendors, however, have built-in management capabilities that automatically flag discrepancies between your development, your test, and your production environments, and they prompt administrators to create a mapping between those environments in order to resolve all those dependencies. Those mappings can all be saved and reused the next time you migrate your policies. That means you can effectively automate all of this dependency resolution. So if migration risk is a concern for you, and it should be, you'll need to ask your vendor what capabilities they have in this area. Here's a good way to think about that. As an example of migration, imagine a situation where you're a cellular provider, and you just had a successful pilot of a new digital service, maybe in your Atlanta area, and now you want to roll that service out nationally. Well, you can manually replicate that service at each of your regional hubs of operation, but given the typical constraints on a telco's IT time and resources, it's probably going to be a slow process and a very error-prone method as well. One that will result in significant delay in time to market. So with a global management gateway solution in place, what does that look like? Here, the telco can migrate their service between Atlanta and their regional hubs, all the while resolving those geographical and deployment environmental dependencies as you go. Then, as your service matures or gets revised or even updated, you can automate the migration of that new version to all your regional hubs. And you automatically resolve all those dependencies and ensure business continuity by eliminating your migration risk. Okay, so enough about manageability. Let's move on and talk about upgradeability for both hardware and software-based SOA gateways. Typically hardware appliances, they run on dedicated servers sourced from one of the big three. It's either IBM, Dell, or Sun for the most part. When those vendors retire their servers, you'll want to move to the latest version of their hardware in order to benefit from the performance boost, but also remain supported on a supported platform. Migrating between hardware servers can be just as simple as backing up your gateway policies and then restoring them onto the new unit. However, some gateways have hardware dependencies. That means that when you upgrade, you can trigger the requirement to rewrite many of your policies. Those policies, of course, need to be retested on that new system, then they need to be redeployed, and you may even have to do some retraining as well. But when it comes to software and firmware upgrades, the story is pretty similar. In most cases, upgrades are fairly straightforward. You just upload the executable to the gateway, you run it or flash the firmware, and you create the update. But some updates can be tied to hardware, and that's triggering what's known as a forklift upgrade. That means in order to gain the new functionality delivered in that software upgrade, you're going to need to upgrade your hardware platform too, no matter whether that current hardware is EOL or not, and then you're right back where you started from. You're going to have to update your policies again, you're going to have to retest, you're going to have to redeploy, and so on. To avoid any surprises when it comes to upgrading, make sure you ask your vendor up front whether their gateway is decoupled from their hardware platform. So we talked about migrating between software and hardware versions as your gateway vendor's roadmap evolves, but what about migrating between deployment platforms as your IT evolves? Today we see a trend with IT teams. They're moving away from physical resources to virtual resources, and that's led primarily by the adoption of VMware systems in development in QA or test environments. But here at Layer 7, we also have about 10% of our customers running VMware versions of our gateway in production environments as well. So as IT becomes more comfortable with their in-house and virtualized systems, they've even begun testing out cloud deployments. How are you going to support that? Well, obviously vendors that offer hardware-only SOA gateways won't be able to help you when you deploy on virtual infrastructure from which the public and private clouds are built. But more importantly, consider the fact that vendor licensing terms, they rarely permit the redeployment of existing licenses to virtual servers or virtual desktops or even external service providers without additional cost. So as far as we know, Layer 7 is unique in not only supporting a wide range of virtual and cloud platforms, but also offering what we call the Freedom License. And that allows customers to freely move their production licenses across their hardware, software, VMware, and AMI form factors. You can move those licenses for the enterprise to the cloud, and there's no additional cost. Now, for most of our customers, that represents not only a significant dollar value, but it also gives extra value in the fact that IT now has the flexibility to move between these platforms without having to wait for their annual budget approval cycle. So that was pretty quick. I hope as we ran through this presentation, you've seen that not all SOA gateways are built the same. And in fact, if you've been following along, you probably realize that the different approaches taken in each of the product designs have resulted in a markedly different impact on total cost of ownership. So let's talk a little bit about that in our conclusions. So when it comes to deployment, for example, multiple form factors give the customer flexibility to choose the most appropriate solution for their purpose or their deployment platform or their budget or their stage of implementation or whatever. It just gives you that flexibility of choice. When it comes to deploying VMware on developer or QA desktops, that can be a significantly reduced upfront cost to you over dedicated hardware in any case. But conversely, if you think about having to install and test a software-based gateway and then certify that for deployment in a data center, well, that can be a costly option too, rather than racking up a standards-based pre-certified hardware gateway. The key here, of course, is just having that choice to match the form factor to the requirements of each of your projects, and that will lower your TCO. Deployment costs are a major factor in the TCO equation, but they're typically just a one-time cost. When you think about operational costs, including ongoing gateway management and administration and upgrading, that represents a far greater impact on total cost of ownership over time. The ability to administer clustered systems across the extended enterprise from a single central point lowers the maintenance overhead, as does the ability to utilize a packaged migration path for hardware and software upgrades. And where most gateway vendors rarely permit the transfer of existing licenses to virtual environments or external service providers, Layer 7's Freedom License can help insulate your organization's budget against change. Finally, the biggest upfront cost beyond licensing, of course, is the cost of configuring and customizing a solution to fit your business and your technical requirements. An all-in-one solution provides powerful extensibility on box without incurring the cost of purchasing or implementing or maintaining a separate app server to run custom code. And you'll want to look for a solution that can be easily extended to virtual and cloud-based platforms as well, thereby preserving your existing investment as your IT needs evolve. Well, I'm going to wrap up here by pointing you at some additional resources beyond just this webinar we've had today. But if you've got any questions about what I've talked about today, feel free to contact me. My email address is shown here. And some other interesting resources you might be interested in include the white paper on which today's webinar was based. You can get that from our Layer 7 website. The URL's listed here. And don't forget to join us for our upcoming webinar on API security with eBay's Chief Security Strategist, Liam Lynch. He'll be talking about how you can securely expose and manage the APIs and services you want to expose to third parties. So that concludes our webinar for today. Thanks for taking the time to join us. Hope to see you again. Bye-bye.